So I'm looking at number 5 on the Unit 1 test retake review, and it gives us a bunch of coordinates. It is helpful to have this graphed, and I understand that unfortunately we can't hand you the graph paper this year, but on the test retake it should be graphed already. You're given some quadrilateral, and our ultimate goal is going to be, I want to know what shape this thing is. Let me try and draw my lines. So we can kind of probably take a decent guess. It does look like a rectangle, but there have been problems in the past that it looks like a rectangle, and when you actually test it, it really isn't. So we got to make a little more sure. So I'm going to be finding the lengths, and I'm going to be using distance formula, which will get tedious because I've got four of these suckers to do. So just a reminder, the distance formula is a version of the Pythagorean theorem. So you will have something squared plus something squared, and you'll solve it by taking the square root. The somethings are your x values being subtracted and your y values being subtracted. And it won't matter the order you subtract in. So I'm going to do that first for points M and A. So I'm going to try and have room for all of these problems. So for segment MA, under the square root, I will have a -2 for an x value, a -5 for an x value. I have to put a minus sign in between it. Then a plus sign. -4, 0, those are my y values. Put a minus sign between it. Then I'm just going to figure out, well, let's throw this on my calculator. What do I get when I type exactly what's under my square root? So I don't even bother trying to evaluate that. I make my calculator do all of it for me. If I could do it properly. Oh my goodness. So many typos. Okay, so 25 is under there, which is really nice because that's a perfect square. I get a length of 5. So it's nice that we didn't have to do any simplification. So next I'm going to find AT. So again, first I'm going to find my x values for A and T. I see a -5 and a 3. Plus, I'm going to do the exact same thing for my y values. I see a 0 and a 6. So I'm just going to take everything under the square root and put it in my calculator. So I will have the square root, and my calculator gave me a 100. That's another perfect square. So we found MA, we found AT. I still have TH to find. I'm writing too big. I'm running out of space. So my x values for T and H would be 3 and 6. My y values are 6 and 2. When I put that in my calculator, I get another 25. And so I still have a side length of 5. And I might have room to squeeze one more in. MH. So M is at -2 for an x value. H is at an x value of 6. M has a y value of -4. H has a y value of 2. When I put that in my calculator, I get 100. Which right away, that tells me a lot of things. I know that we have 2 pairs of opposite sides. So I know it's not a square. I mean, I didn't think it was a square because I can see the picture. But I have proof now that it's not a square. I have 2 sets of equal sides. It could be a parallelogram. It could be a rectangle. It cannot be a rhombus. So I'm going to go ahead and answer part D. Not a rhombus because there are 2 sets of congruent sides, not all 4. But I actually don't have proof that it's a rectangle. I don't know if I have right angles until I check the slopes. Now, conveniently, I did graph mine, so I don't have to use the slope formula. You absolutely could. I'm just going to count rise over run. So I'm going to just go down here. Here's a rise and my run. So when I count that, I see 1, 2, 3, 4 squares, and I went down. Then I'm going to the right 2, 3 squares. So MA, I'm going to put it over here, has a rise of -4 and a run of +3. I'm going to follow the same process for AT. So I'm going to trace first my rise and my run because it's going to get a little crowded in this picture of all the things I'm doing. But I'm just going to count my squares. 1, 2, 3, 4, 5, 6 squares, and I went upwards, so it's positive. Run 2, 3, 4, 5, 6, 7. I ran 8 squares, and I went to the right, so it's positive, which means AT has a slope of 6 over 8, which can reduce. Next, TH. I guess I could count this way. Personally, I usually try and not go inside my shape, so I'm going to count up and then left. If you want to go down and then right, you will get the same answer. 1, 2, 3, 4. I have a rise of positive 4 because I'm going up. 1, 2, 3. I have a run of negative 3 because I went left. But no matter which way you went, you always put the rise number over the run number. And then lastly, I have a rise here and a run here, so I'm going to count those. 1, 2, 3, 4, 5, 6. I went down 6. 1, 2, 3, 4, 5, 6, 7, 8. I went left 8. So I'm going to put my rise amount over my run amount. Negative over negative makes a positive, and it reduces. I have all my slopes. So I can actually answer the rest of D at this point. I do have right angles. The only way you will prove right angles on a graph like this is by looking for opposite reciprocals. Negative 4 over 3. If I flip it over and make it positive, I get 3 over 4. Because I have consecutive slopes that are opposite reciprocals, I know I have right angles. Which means I now know it's not just some generic parallelogram. The best name for this thing is a rectangle, which I kind of guessed in the first place, but now I know it's a rectangle because I have 2 pairs of equal sides and I have right angles. Which means if I want the perimeter and the area, I just need to, for perimeter, add up all my sides, which I found in part A. So I have a perimeter of 30 units. And the area for a rectangle is just going to be length times width, which would be that 10 length and that 5 width. So 50 square units. I did skip part C mostly because I don't really have space for it, so I'm just going to throw it down here. For the midpoint formula, it's very much like what you had to do in problem 1 where you average, but you're going to have to group your x's for your first average and then group your y's for your second average. Which means for MA, I need to go find what numbers are my x's and y's for these. And I see negative 2 and negative 5 are my x's. So I will add negative 2 and negative 5 and cut it in half. I will do the same thing for the y coordinates. Add the negative 4 and the 0, cut it in half. So I'm going to get half of negative 7 and half of negative 4. You could leave it as negative 7 over 2, that would be correct, or just negative 3.5, negative 2, just an equivalent form of the same thing. So if you actually watched this whole video, I am very impressed with you, and I appreciate your determination to get this whole thing done and to try and get an explanation. I went through it quickly, so rewatch anything you're still confused on. Email your teacher if you're like, I need this re-explained, that lady did a crappy job or whatever. But good for you for